Shalom lechulam. Hi everybody, I think we need to talk English, right? Is it in English? Everybody here speaks Hebrew? You speak English? Good, so we'll do it in English. So hi everybody, welcome and thank you for joining me at this late hour here in Jerusalem. It's a pride and privilege for me to be here. This is my hometown. I was born here oh so long ago. Today's session is going to be, well, this is really weird, sorry. Today's session is going to be about Redis. And first and foremost, let me introduce ourselves, or myself. My name is Itamar Haber. I'm Chief Developer Advocate at a company called Redis Labs. We are a commercial provider of Redis software, and we're also the home and open and sponsor of the open source, thank you, Redis project. What is Redis? Does anyone here know what Redis is? Or anyone who knows what Redis is, raise your hand. Those who don't, raise the other one. All right, cool. Before I tell you what Redis is, I'd like to open with the one joke I know. So take your time, read it. It's not that long. And I want to tell you about 10 things about Redis before I go on and tell you about what I really came here, which is probabilistic data structures for real-time analytics in Redis. And that's a mouthful. By the way, you'd be surprised to know that there is actually another session in an hour by Yoav, whom I worked with before, about the same topic, only different data structures. So if you're interested, go and follow it up. It's not Redis related, his at least, but mine is. So Redis is a remote dictionary server, and you spell it like that, but you read it like Redis, not Redis. It's open source, as in the sense that the source is open. You can just go ahead and grab it, but it's also licensed under the very permissive BSD style 3-clause open source license, which is pretty awesome. You can just use it wherever you want. It's an in-memory database, that is, everything is stored and served from RAM, hence it's very, very fast. And it's a database for, about 9 data structures, or all in all. Core data structures. It's developed and maintained by a certain individual. Oh, by the way, is there a clock here? Okay. You're mine. It's developed and maintained mostly by a really amazing fellow called Salvatore Sanfilippo. Those of you who speak Hebrew, today there was an article about him in the Haaretz. Those of you who speak English, the translation will probably in later. Thank you. I can't read that kind of much. About him, he's doing it for the last 7 years, mostly alone. Lately, we've been helping him a lot, and he's been working with us and for us, so everything's peachy. Just recently, the other month, we had the next best version, which is dubbed 3.2. I'm not going to talk about it. I've been talking about it up until last month. Now I'm into totally different things, namely the next version, version number 4 modules. But what is Redis? It's often been called the Leatherman of databases, so it's mostly used as a database or as a cache or as a broker, a message broker actually. But again, I'm not going to touch that or any of the other very notable features, and I just put a couple there just to give you a taste of what it can do. All that you can find online. I've been giving talks about it for the last 3 years. Or just come to me, I'll teach you anything you need to know about Redis. But today, I just want to tell you between 2 to 4 reasons why Redis is the best thing for real-time analytics. And after that, it's going to be less marketing, more real stuff. So there are 3 reasons. The first reason, which I could show you benchmarks on and graphs, and by the way, if you've been to the keynote session, our co-founder and CTO gave his presentation. You could see all kinds of graphs. So you heard him say, it is very fast, right? So Redis is very, very fast. That's all I'm going to say about it for the rest of the day. The next thing I want to show you about Redis, which is also a good reason to use it, is how simple it is. Now, I could spend the entire day doing that because it's very simple, or I can do it in 3.5 slides and then be done with it and then get to my topic today, which is versatility, and that's until they'll tell me to stop or or the last one of you will leave. That's what usually happens. So what is Redis? Redis 101. So Redis is NoSQL. NoSQL, you take it as you want. It just means that, well, we're going to have probably something called RQL or something sooner or later, but it's not a relational database. What it is, it's a key value store in the sense that everything is accessible by a key name, a primary key, just like in a table in a relational database. Everything has a key, so you access stuff with the key, but then there's just a value. There's nothing relational about it. The thing is, with Redis, the value can be a data structure. So you've got a key that points to a data structure, which then in turn points to the actual data inside it. That's simplicity. Because Redis isn't a relational database, I wanted to just capture in this little diagram here what I think is the essence of Redis. These are, in fact, the 9 different data types that Redis supports. I'm not going to go into each one and tell you why this one is best for analytics. All of them are actually very useful for analytics. Take the strings, for example. Strings, you do a lot with strings, either stored properties or maybe counters. Redis's strings are also numbers, so you can increment them and do math on them. But then there are hashes and lists and sets and sorted sets for membership and sorting through stuff. And then there's a whole bunch of other data structures that are like just God sent or Salvatore sent to analytics, in the sense that this is what they're aimed for. You got your bitmap and your bit fields, which can be used to store bits or varying with integers in Redis. You got your hyperlog log. Everything is really, really interesting in Redis, and this is just standard Redis. I'm not going to talk about this today. What you do need to know in order to start working with Redis from, like, after I finish talking and let you go, is you pick your language of choice. So let's say you like to do things in Python, and while the lady there likes Java, or someone's using R, MATLAB, or even Spark, or even other languages like more esoteric ones like C or Ruby or Node. Whatever you pick, you got 147 open source clients you can pick from. Everyone are using them. All of them are almost production in the sense that we're using them, we know them. And then you do 2 things. The first thing, you take this client and you tell it, make a request to the server, like ping, and then the server responds with a response like pong. And that's all there is to know about Redis. So here's a demo. I don't do live demos. It's too frightening. I've captured a demo. Databases are very, very imaginative. You can see a lot from this nice diagram here. So this is just a basic interaction. You can see how I'm taking a field, a key called counter. I'm setting it to the value 1. Redis says it's 1, but it tells me it's a string. It's the string called 1. But then the next command, and all of these are commands for Redis, are specific commands for Redis. Redis has about 180 of them. The next command is incr, which is a short for increment. So Redis increments the value as if it's a number and returns the number 2. Then I go and append to that number another string. Then I do a get set operation, which is atomic. I'm setting and getting the entire thing in one fell swoop. Very cool stuff. That's Redis. End of thing. Let's talk about versatility, which is the third little cube I showed you earlier. What's versatility? Here's my take on versatility. Versatility is made up of 3 things. Flexibility, which we had in Redis from first version actually, which means you can take data structures like lists or like hashes and put them together in ways that make sense to you for your processing need. You do it because it's very fast, okay? Then about all the rest of the time we spent about composability, right? Composability is the fact that you can take these little nuggets, these building blocks, and put them together, not only in ways that make sense, but in ways that are consistent. So we had transactions added, and then we finally, in version 2.6, even got the ability to compose scripts that run in Redis using Lua. Very cool stuff. I've been doing a lot of that, but Lua takes you only so far. Lua is a scripting language. It's a little slower than others. You can't do really massive number crunching with Lua. So in the newest version, what we're going to get is extendability. And this is the topic of my lecture, extending Redis basically with modules. Modules are the newest, hottest things out there. We've just launched them last month. And here is what they are. So they're basically just dynamic loaded libraries. We've had these for a long time all over the place, and everyone knows what a plugin, an extension, a module is. So they're just libraries that the server can load during runtime. The nice thing about Redis modules are that they're future-proof in the sense that a module that I compiled today can be run with future versions of Redis, which is pretty amazing, especially for people like us who actually use Redis a lot and we don't like to maintain everything. Modules are gonna be written mostly in ANSI C. Redis is written in C and the modules API is C, but that doesn't mean that someone brighter than myself for sure can take, for example, Python and just do C binding to it, or maybe we'll see Java running in Redis in one of these days, who knows. And they use an API that the server provides for you, the module developer, which is nearly as fast as the core native Redis commands, and the plan is to release them later this year. Of course, I could spend the entire time I had now on what are the modules, how do you write them, do maybe a walkthrough, but this is not the talk I'm going to give. I just want to give you a taste of what the API looks like, and it's pretty sane. There's actually one big layer there that's about administration, registering your commands, your modules, memory management, all that good stuff. Then there's another layer called the high-level API, which is like having a little client inside Redis, and you do the same operations, the gets, the sets, the incurs, just the same way, but you're calling them from inside Redis. So it's very fast and very efficient. But the best way to utilize Redis is to actually go all the way down to the low-level API, which gives you access to memory, actual data memory of the server and core data structures. And we've done a little benchmark just to get, initially just to understand what's going on here. So this benchmark is on a laptop. It's a sorted set, which is a data structure. It has 1 million elements. Each of them has a score, and we're just summing up these 1 million elements. The first row up there is a local client, a Python client. So there's a Python script that does the gets and sums them. Everything is on the same laptop, so the network here is very insignificant. It's just overhead of the kernel. If in real life, the Python script would have probably be run from a different machine, and then you'd have to add in the network latency itself. The second line is an embedded Lua script, which runs in the server itself, so it's actually comparable to the Python, but it is running locally right against the data. And the third line is the high-level API, which is faster, still about 15, 17%, 20% faster. I don't know how to do the math, but it's still pretty much faster than all the rest. But then you go to the low-level iterators API, and you see where this API is going to make a real difference. This is where we're going to get a real boost with APIs, with that API. So I told you I know about one joke. You should remember that this talk is about statistics. And I didn't put that joke there just to mess with you. It's about statistics, and what I'm going to show you today is what I've done with modules over the last month or so, just before we launched it actually. And these are things called probabilistic data structures, or PDSs. no one else calls them PDS, but this fits in a slide. So in the next slide, I want to show you PDSs. And it ties to the first joke because, or the first funny thing that I tried saying, because we said there are two kinds of people, there are three kinds of people actually, or three kinds of data structures, right? The ones who can count and the ones who can't. But there's a third kind apparently, it's the ones that can and can't count. And these are exactly the PDSs. These are the data structures of the third kind. So what are they? Before we show them, we'll say, why do we need them? When can you count something but can't count it in the same time? So there are lots of problems, especially when you're talking about big data, that you can't actually count, or in theory you can count anything. Let's say the number of unique visitors on your website per day. Sure, you can count that, but if the numbers are too high, maybe it's just impractical. So instead of actually counting the number, we can try estimating the number. And for that, for example, we have the hyperlog, which is a very fascinating data structure that Redis already has native embedded in it. So I'm not going to talk about it. It's just an example. What I am going to talk about are a couple of good PDSs that I've met and that are fairly simple to implement with the API. What all of them basically, or what we're looking for a good PDS to be, is some general abilities or properties, if you will, like the fact that they need to be efficient. They need to be more efficient than the trivial, naive solutions that for the problem that we're trying to solve. So they solve the problem in sublinear space-time something. They need to be accurate, but within reason. We are talking about probability. We are talking about statistics. So we can live with some uncertainty as long as we know what the probability for that is. And they need to be somewhat scalable, at least in the sense I don't want to set up everything from the beginning and know exactly where I'm going to. I want to make sure that they can grow and utilize more resources if I need them to. So the first such data structure, which is very fun to meet because the entire algorithm is actually what you're seeing here. So since I'm using extra large fonts, it can't be that hard. And basically it says, I want to solve the next problem. I want to, at every given point in time, given a stream of items or a stream of samples, I want to get the top K, K being a parameter for this data structure. I want the top K items that I've seen. So yeah, sure, I can just save all the items and sum them up and sum their counters and see what surfaces, but I'll be saving a lot of long tail, a lot of low probability observations and be wasting a lot of space. So top K does that. Here's the algorithm. The entire thing is online, both my slides and the algorithm. I didn't make it up. There are actually proofs about it, or everything that I'm going to show you, so you can read later on. And coming to think, trying to model this module, or trying to model this problem with a Redis module, or just on top of Redis, is almost trivial if you know your Redis. I'm not suggesting that it's trivial to one who's just looking at that. I remember the first time I saw this bunch of garbage. These are actual Redis commands down there. It's scary as hell, but like anything, you grow into liking it, and then you don't understand how things can be actually different. A sorted set, in a sense, is just a set, a lot of members in it. Every member has a score, so you can treat them as name counters. This is exactly what the algorithm describes. This is exactly how we implement it, and I've shown some of the commands, like Z-score is a membership test. Z-add, I can add members or update their scores and so forth. And when you consider doing that after you've developed it, this is how interacting with a Redis module looks like. Just as simple as that. So in the first line, I've preloaded this module into Redis, and I've called it with the very imaginative name top K. And then the first command just says, all right, I want to add to a key, to a data structure called TK, again, my creativity here, which has K of 2, because I don't want to take too long. Initially, this took, like, I wanted to show it with a full 100 body item with and 100, like number 100 had 100 samples. So my first 50 slides were like just building this sets. So then I shrunk it down to 2. So we have number 2, and I'm adding A once, and TK says, okay, 1, I've added it, and then I'm adding B to it twice, once after the other. And you can see what TK says, it's not that important. And then I'm doing a Z range with the scores, which is a Redis command, and I'm getting all the elements and their counters, which is pretty basic, right? But everything is done in Redis, and it's very fast. And at the end, you can see that I'm trying to add C, and then I get back -1, which means, listen, dude, it's only a K2 kind of set, so we need to evict something. And in the next slide, I'm going to show you how it's actually been evicted. You can see that C got shoved in instead of A, which was 1. And the nice thing, and I'm not going to talk too much into it because I see people yawning, is that there's actually an optimization there. The original algorithm called for decreasing all of the sets items if you need to evict something. Here instead, I took a cheap trick and I'm just keeping a global offset at some dark corner of the data structure, so I don't actually need to iterate the entire set. I'm using all kinds of stuff there. It's very fun to make, thank you. Bloom filters. Have you heard about Bloom filters? Anyone here heard about Bloom filters? Oh, good. So about half of you. Excellent. So the other half, listen, this is one of the coolest things there are. You wouldn't imagine how simple it is and how effective. The idea is avoiding hard work. Now, I was born lazy, and I'll probably remain that way. They're good for asking the question or giving a good answer about, have I seen this thing before? Like, you've got the database. You want to know if a certain user is in the database or not. One trivial way of doing that is going and asking the database, select from users where user, but that costs in something. So in other ways, taking the entire data and moving it to RAM, to Redis, but that costs too. But then you can go ahead and do a Bloom filter. A Bloom filter is sort of a summary of the data. It doesn't really hold the data, but it can give you a good answer about whether it's seen the data or not. And the good thing is that it says, I won't give you no false, I won't give you false negatives. I knew I'd mess this up. So the one thing it's good for, I won't give you no, I can't do double negation. Man. So if it says no, it means no, I haven't seen it. But it could say, yes, I've seen it, and without really meaning to. And the error is bound, so it gives you a pretty good sense of what you want to do. It's all a matter of dimensioning your Bloom filter. And after you've taken the care of actually implementing it, or if you'll use my module for that, it looks like that. There's a counting Bloom filter that I implemented. I'm adding it to the Bloom filter, the element A and B, and then I'm checking whether A and B is there, or are there, actually. And I'm getting back the response 1 and 1, because they are indeed in the Bloom filter. However, when I check for C, it says that C isn't there. And I can be sure that C isn't there. There are no false negatives, but it could have returned for C, actually the answer 1, and have misled me. The way a Bloom filter works is very unintuitive, but after you think about it a little, it becomes more comprehensible, I guess. There's an array of bits in the classic Bloom filter. The array is of single bits. And this Bloom filter, actually, it's an array of 4-bit integers, so I can actually count there. And the array I set according to the hash value, and I keep here just 2 hash functions. A good Bloom filter will have probably more than 2 hash functions, but for each value that I put, I hash it twice, and then I set the bits, the corresponding bits in that array for having seen it. And when I need to check for something, whether it exists, I do the exact opposite. I hash, I go to these bits or these counters and try to see if there's something there. If all my hashes for a given sample are 1, I know that I've seen that sample. Of course, there is a probability of hash collision, like you see over there, and that is the reason why there could be false positives. If you think that's weird, you better prepare yourself. So Redis Blooms is the Redis module that does that. The default error rate is 5%, but that's configurable. You give it, you can initialize the data structure a priori to tell it that you want another error rate. The capacity is 100,000 cents, but again, that's adjustable. And it comes in two flavors, actually. One that's a counting Bloom filter, the one I've shown you, and there's another variant there that actually takes multiple counting Bloom filters and combines them. So if you exceed the capacity, it just adds another Bloom filter, but that has to be in a certain layered fashion, so there's a structure wrapping the entire thing. But if you've thought that Bloomies are weird, then count, min, sketch is not a comedy short stand-up from the phone count from the Muppet Show. Count, min, sketch is actually a very real counting data structure. It's very much like Bloom filters and unlike top K, so in the sense that unlike top K, actually I can ask it for a given item, give me its frequency, or give me the number, the count that's associated with it. And for any item, it will be able to do it. The top K that I've shown you at the beginning can't do that. It can only tell me these are the top K right now. I don't know what I've seen earlier. The stuff that you deleted is gone. So this one can actually answer about anything with an error of sorts. It's like the Bloom filter because it does uses hashes as indexes for its counters. But unlike the Bloom filter, what this does is it uses them differently. I think I'm just running out of time, so I don't want to take the time for the next guy. I won't go into all that I plan to do here. But the entire thing is first, well, blah, 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 right? Very important. All this is for you to grab. It's open source, so you can go to redismodules.com, which links to all these modules. You'll need the latest Redis, of course. Redismodules.com. Iftach told you about this earlier, so go to redismodules.com. If you want to read more about what we've talked today, there's some reference material here. Thank you very much for being such an attentive audience, and have a great day.